Chemistry at Neuric Academy can sometimes be thought of as intro to problem solving. And becoming a good problem solver is going to be crucial for your success in this class. So your textbook gives you one method. There are a variety of methods, and we'll be talking about problem solving a lot throughout the year. So one of the things that you have to get used to doing is kind of running through a bunch of steps in your head. Okay, we're going to write them out at the beginning, and you'll continue to write them out until you get comfortable with the process for problem solving. Okay, so here I have all the steps written out, and here I have a sample problem. Now, granted, this is a very, very simple problem, and you could probably solve it without using these steps. But I want you to practice applying these steps to a simple problem so that when we go from a one-step problem to like a 10-step problem in the spring, you have the tools in your toolbox to handle that, okay? So, first step, analyze. Read it twice. Identify the given and the unknown. Sometimes when I'm working through these, I like to use a highlighter, okay? And I like to highlight the things that I'm given. Except for I don't need the biggest highlighter this world has ever seen. So here I have a mass, okay? And I also have, let's choose blue, I have a density, okay? So I'm trying to find the volume. That's what I'm trying to find. So maybe I'll write a little question mark over this, okay? Trying to find the volume of a sample of liquid mercury that has a mass of 76.2 grams, given that the density of mercury is this, okay? Identify the given and the unknown. So in my analyze step, I need to know what I want, okay? Wanted is the same as unknown. And I want to find the volume. And oftentimes, I'll be able to figure out my units, volume in milliliters. Sometimes problems will ask for specific units, sometimes they won't. So just go by what the problem says. My given is a mass, which is 76.2 grams, and a density, which is 13.6 grams per milliliter. Okay? Now, next step. This is a very important step that people try to skip, and then they don't have a plan, and then things go badly. Plan. Draw a diagram. Map out the steps. Figure out what conversions you will need. Find information you need, maybe from the periodic table. I don't know. Maybe we'll use that, I don't know, every day in the spring. Okay? There are certain things that you need to figure out what you have to do. Okay? I'm a big fan of mapping out the steps, working from what you need to what you're given. Okay? So I usually start on the end here, and I usually start out with my volume in milliliters. That's what I'm trying to find. Okay? And I know that I can find that from mass in grams using density. Okay, that's really it. That's kind of all I'm looking for. All right. Now, the next step is to solve. Okay, this is what people try to jump to before they're ready. But now I have a plan. All right, I'm going to go from the mass to the density. And the solve is usually in chemistry just a dimensional analysis problem. Occasionally, you'll need to solve for the variable that you want, okay? But this time, this is just dimensional analysis. So question mark milliliters equals 76.2 grams, okay? And then I write my grams down here. And I know I have density, which converts between mass and milliliters and can be either grams per centimeters cubed or grams per milliliter in their equivalent. So that's, I'll put milliliters on top, and that's 13.6 grams over 1 milliliter. Okay? And my units cancel out, and I know that I'm solving for this milliliters. So when I do this, the answer that I get is 5.6029 milliliters. Okay, now step 4. Oh, sorry. Calculate answer, cancel units, round to the correct number of significant figures. Well, this has 3 significant figures, this has 3 significant figures, so this number also needs to have 3 significant figures. This is less than 5, so it stays the same, 5.60 milliliters. Now the last step in problem solving, and this is one that a good problem solver would do that a lot of mediocre problem solvers just skip, okay? This keeps you from being great. Check your work, okay? Oftentimes we'll be working with these crazy numbers in scientific notation, and scientific notation is great because it makes it really easy to estimate, okay? So I like to just kind of throw in simpler numbers and divide away, okay? So for example, in this one, this number is really just 75, and this number is really, it's very close to 15, okay? These numbers work for a great estimate, okay? That's 5. 75 divided by 15 is about 5. So I know that as long as my answer is around 5, I'm pretty good. Now, there will be times when, honestly, I'll be looking for numbers with the right power of 10, okay? Who cares about the coefficient? I'm just looking for the right power of 10. This time I can be a little bit more specific because my estimates are so close, all right? And that's it. I've solved the problem, I've checked my work, I've come up with a plan, everything I've done by the book, all right? So use this while you're getting used to it, and then you can build up to more complex problems later.